Hello friends, I welcome you all to my channel. In this video, I will solve the problems and limits of exponential indeterminate form of the DPP sheet number 4. So let's get started. Okay, so let's solve the problems. The first problem says limit x tending to 1 minus 1 x to the power 4 plus x square plus x plus 1 divided by x square minus x plus 1 whole to the power minus 1 1 minus cos of x plus 1 divided by x plus 1 whole square. So we have here x fx equals x to the x to the power 4 plus x square plus x plus 1 x square minus x plus 1. Now when x tends to minus 1, this implies fx will tend to minus 1 4 divided by this is 2 by 3. So fx is tending to a finite value 2 by 3. This means the exponential, the power must also be tending to a finite value. So this does not fall into the category of the exponential indeterminate form 0 to the power 0, infinity to the power 0, or 1 to the power infinity. We simply see that fx is tending to a finite value 2 by 3. So now we have to find the limiting value of the power. So here gx equals to by now limit x tending to minus 1 gx. So we we already have, we see here limit x tending to minus 1 fx equals to 2 by 3. Now limit minus 1 gx equals to limit minus 1 1 minus cos of x plus 1 x plus 1 squared. We can substitute, we can putting x plus 1 as t, in this implies t tending to 0 as x tending to minus 1. So the limit becomes limit t tending to 0 1 minus cos t squared. This equals 1 minus cos t equals 2 sine square t by 2. This is the standard formula, trigonometric formula we know. Now we would like to restructure this limiting function so that we have sin x by x, and we can apply the standard result, limiting value of sin x by x at x tends to 0 is 1. So we write this, we adjust t square by 4 and we already have t square. So this becomes t square cancels out. This becomes half. So therefore uh, limit x tends to -1 fx to the power gx, where fx is the function x to the power 4, this rational function, and gx is the 1 minus cos x plus 1 by x plus 1 whole square. So this becomes 2 by 3 to the power half. This is the answer. Let's see the next problem. It says limit x tends to pi by 4 to minus 2 minus tan x to the power 1 by log e tan x. Let's check the indeterminate form. Here fx is 2 minus tan x and gx is 1 by log e tan x. So when x tends to pi by 4, we have fx tending to 2 minus 1, that is 1, and gx tending to log e 1, this is tending to 1 by 0, this tends to infinity. Therefore here the form is 1 to the power infinity form. So now we directly using direct formula of 1 to the power infinity, we know the, the result is gx into fx minus 1. This becomes e to the power limit x tends to pi by 4 fx minus 1. This is 1 minus tan x by log e tan x. Now this limit becomes of the form 0 by 0 because this is of the form 0 by 0. Now we can apply L'Hopital rule and we get minus sec square x divided by sec square x tan x Mm, 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 mm. Okay, this becomes e to the power x tends to pi by 4 minus tan x. Now we can substitute the value of x pi by 4 and we get to the power minus tan to the power minus 1 is the answer. Let's see the next problem. It says limit x tends to 7 by 2 to x square minus 9x plus 8 whole to the power cot of 2x minus 7. So fx is 2x square minus 9x plus 8. Gx is cot of 7. When x tends to 7 by 2, fx implies fx tending to 49 by 4 minus 63 by 2 plus 8 uh, 49 minus 63 plus 16 by 4 this equals 65. 7 by 2, 63 by 2, 16, 65 to 7 by 2, 49 by 4, 49 by, this will be 49 by 2. So this is 2. This equals 1. So fx is tending to 1 and gx is tending to 2x minus 7 when x is tending to 7 by 2 is 0. So cot of 0 implies 1 by 0 implies infinity. So the form is 1 to, to the power infinity form. So we can directly apply the formula for 1 to the power infinity using direct formula of 1 to the power infinity. We get this equals e to the power limit x tends to 7 by 2 fx minus 1 fx minus 1 is 2x square minus 9x plus 7 divided by gx is tan of 2x minus 7. This equals to the power limiting value of x tending to 7 by 2, and we can factorize the numerator as 2x minus 7 x minus 1 divided by tan 2x minus 7. So we can apply x tending to, okay, so this is we know x minus 1 applying the standard result, limiting value of tan x by x when x tends to 0. Over here we have 2x, instead of x we have 2x minus 7, and when x is tending to 7 by 2, 2x minus 7 is tending to 0. So we can apply that standard formula. So this becomes e to, e to the power 7 by 2 minus 1 by 1. This is e to the power 5 by 2 is the answer. Let's see the next problem. This was number 3. Number 4 says limit x tends to 0 sine square by 2 minus px to the power 6 square pi minus 2 minus q x. So when x is tending to 0, fx is tending to sine square pi by 2, which is 1, and also gx. So we have fx sine square pi minus and gx. So when x tending to 0, we see implies fx is tending to sine square pi by 2 tending to 1, and gx is tending to sec square pi by 2 tending to 1 by 0 tending to infinity. Therefore, the form is 1 to the power infinity form, and we can use the direct formula. So using the direct formula of 1 to the power infinity, we get the answer as e to the power limit x tends to 0 gx into fx minus 1. This is gx 1 by cos square pi by 2 minus qx and sine square. Okay, so sine square pi by 2 minus 1 by cos square pi minus mm, this becomes e to the power limit x tends to 0. This is from the numerator we have sine square this minus 1. We can write as minus of 1 minus sine square pi by 2 minus px, and using the formula sine square plus cos square x equals to 1 minus cos square x, we get minus cos square pi by 2 minus px divided by cos square okay. This is e to the power x tends to 0. We bring the minus outside and write two minus qx whole. We we can rewrite this the expression like this. Now uh, the limiting value, we know that limit x tends to a, uh, fx square of fx equals the square of, we know this formula. So using this we get the result as minus so the square becomes the limit get inside and the square comes outside, so we have this thing. Now we just need to find the limit of cos of pi by 2 minus px divided by cos of pi by 2 minus qx. So this thing, um, this limit, let's calculate this limit separately. We have limit x tending to 0 cos pi 2 minus px divided by cos of pi by 2 minus qx. This is of the form 0 by 0. In applying L'Hopital rule, we get limit x tends to 0 minus sine pi by 2 minus px and then minus pi by 2 minus px whole square and then minus p divided by minus sine pi by 2 minus qx multiplied by actually this will be also pi square, so minus pi square 2 minus qx whole square multiplied by minus q. So after differentiating the numerator and the denominator, we get this. And this is um, pi square. Pi square cancels out, and if we now substitute x as 0, we get sine of pi by 2 minus px becomes sine of pi by 2. It becomes 1. Also, the sine of pi by 2 minus qx at x equals to 0 becomes sine of pi by 2 becomes 1. So this becomes 1 into 0. Uh, this becomes minus pi square 0 by 4 minus p minus q. This is p by q. So the final answer becomes e to the power minus p by q square. This is the answer. Okay, let's see the next problem. Number 5. It says limit x tends to infinity 20 to the power x minus 1, 19, 5 to the power x whole to the power 1 by x. Now if x is 20 to the power x minus 1, 19, 5 to the power x, at x tends to infinity, okay, uh, this equals 4 to the power x into 5 to the power x minus 1, 19 into 5 to the power x. If I take 5 to the power x common, I get this thing, and this ultimately becomes this. So x tending to infinity implies fx will tend to 4 to the power infinity 19. This is infinity minus 0, this is tending to infinity, and gx is 1 by x. So x is tending to infinity, so gx tending to 0. So the form is infinity to the power 0 form. Okay. So in this case, we have to apply the general method for solving exponential indeterminate form. So we let y equals to the given limiting function, and then we take log of the limit. We bring the log inside and we get this is log of y becomes this. Okay. Hmm. Hmm. Log is in the form of log a by b. We know log of a by b equals log a minus log b. We can simplify using that formula, and x becomes in the denominator. Let's see this thing. Okay, so this is fx. So fx is tending to infinity. Fx is tending to infinity. So log of fx will also tend to infinity, and in the denominator we have x is tending to infinity. So this whole limit expression is of the form uh, infinity by infinity. But let's first simplify it. This becomes log of we have this. Now we apply L'Hopital rule and get mm, 20 to the power x minus 1. We differentiate this. What do we get? 20 a to the this is log a 20 divided by minus 1 minus 1 by 20 to the power x minus 1, and then again differentiate 20 to the power x, which is 20 to the power x into log e 20. This becomes 1 by 19 into 5 to the power x, and then again differentiate this. This equals log e5 1 by x into log 20 to the power x minus 1 19 5x 20 to the power x minus 19. We could have also applied it's 19 into 5 to the power x. We could have splitted that to log of 19 plus okay. Mm. 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 Log 20 minus 1 by 9 x. Mm. 80 to the power 80 to the power x. So in this case, this gets cancels out. Infinity. This becomes 20 to the power x log e 20 minus log e 5 plus log a 5. Divided by 20 to the power x minus 1. Okay, this is limit tends to infinity. 20 to the power x log 20 minus log e5 plus log e5 divided by this is x to the power tending to infinity 20 to the power x log 20 by 5 minus 1. If I divide every term by 20 to the power x, we get log of e20 by 5 is log of e4 plus log of e5 divided by 20 to the power x by 1 minus 1 by 20 to the power x. Now when x tends to infinity, 20 to the power x also is tending to infinity. So the 1 by 20 to the power x will become 0. Also the log e 5 by 20 to the power x will become 0. So this becomes log e 4 plus 0 1 minus 0 log e 4. So we get log of limit x tending to infinity y as log e 4. This implies the final answer limit is 4. Okay, let's see the next problem. It says limit x tends to infinity 1 plus x whole to the power x divided by x to the power x multiplied by e and this whole to the power x. Clearly, mm, so we have fx as 1 plus x to the power x by x e. This is 1 plus x by x whole to the power x 1 by e and this is 1 plus 1 by x. Now at x tends to infinity we have a standard result that 1 plus 1 by x to the power x is e. Uh, uh, we know this as a standard result is e. Therefore, uh, when x tending to infinity implies fx tending to 1 and gx is x implies gx tending to infinity. Therefore, the form is 1 to the power infinity form and we can directly apply the formula using direct formula of we get the result as e to the power limit gx into fx minus 1 hmm. Okay, this is e to the power gx is x and fx is 1 plus 1 by x to the power x 1 by e minus 1. Okay. Uh, hmm. Okay. This is limit x tends to infinity. Hmm. Let's x tends tending to infinity. So this is having now this limit is having the form uh, fx is tending to 1, so fx minus 1 will tending to 0 and x is tending to infinity. So this has now the form infinity into 0. And we can transform this into 0 by 0 or infinity by infinity form, but I am not sure how to differentiate 1 plus 1 by x to the power x. Then alternative method is to use the expansion of expansion of e uh, minus 1. So if I take the e common, just try to simplify it. If I take the e common, I get x by e and 1 plus 1 by x to the power x minus e. Hmm. We can use the expansion of 1 plus 1 by x to the power x. But okay, so the 1 plus 1 by x to the power x can be rewritten like this. Uh, we know that n equals e to the power log en for n some greater than 0. Using this formula, we can write 1 plus 1 by x to the power x as e to the power log e mm, mm. Let's first convert the limiting variable from infinity to 0. It will be easier. So let 1 by x equals to t implies t tending to 0 as x tending to infinity. So this becomes limit t tends to 0, 1 by e t e to the power log 1 plus t whole to the power 1 by t minus e. Uh, this can be simplified further as 1 by et, the power of the log. The power comes in the front and we get uh, log e 1 plus t by t minus e. Now we have to use the expansion series of log 1 plus x. Log e 1 plus x equals x minus x square by 2 plus x cube by 3 minus x to the power 5, so on. Using this formula, we get e to the power limit 1 by et. So we have now, if we substitute log 1 plus t by its expansion series, we get t minus t square by 2 plus t cube by 3 and so on, like this, minus e. This becomes e to the power limit t tending to 0 1 by et. Over here, if I multiply the 1 by t, bring the 1 by t inside, we get 1 minus t by 2 plus t square by 3, like this, minus e. This equals, we can over here we can okay, so this equals 1 by et. We take e common and put the rest inside. T by 2 plus t square by 3, this, minus e. Okay, and then we take e common, bring it out, and it gets cancelled by the outside 1 by t, and it becomes 1 by t e to the power minus t by 2 plus t square by 3 and so on, minus 1. So we have e to the power something and minus 1. So again, okay, we have to use again the expansion series of e to the power x, which is, what is the expansion series of e to the power x? 1 plus x square by 2 factorial plus xs cube by 3 factorial and so on. If we use this formula, we get e to the power 1 by t uh, 1 plus minus t by 2 plus t square by 3 plus minus t by 2 plus t square by 3 square and so on, minus 1. So 1 gets cancelled and we are left with 1 by t. 1 gets cancelled, so we are left with minus t by 2 t square by 3 . like this. Now from the first term inside the bracket, we can take, okay, so we bring the outside 1 by t inside, uh, and we get minus half we get minus half plus t by 3 and the higher powers of t plus uh, this is squared. So mm, so basically if we bring the 1 by t inside, the only term that will be independent of t is minus half. All the other terms will have some power of x. So minus half plus t by 3 and higher power of t. So and we substitute t, all these terms will be 0 from t by 3 and the rest of the terms will be 0. So this will become e to the power this becomes e to the power minus this becomes e to the power minus half. This is 1 by root e. 1 root e is the answer. Okay, so let's see the next problem. This was 6. 7, limit x tending to 0, 2 by x cube tan x minus sin x all to the power 2 by x square. So gx is definitely gx is 2 by x square. So x tending to 0 implies gx tending to 1 by 0 tending to infinity. So it is having a indeterminate form, like it is the power is infinity. So for this limit to exist, we must have the base, the power limiting value of the base, that is 2 by x cubed multiplied by tan x minus sin x, that has to be its limiting value has to be 1. Only then we will get the indeterminate form 1 to the power infinity. Just for the sake of confirmation, we can check if x equals to uh, 2 tan x minus sin x x cube. It is of the form 0 by 0. So we can apply L'Hopital's rule and we get limit x tends to 0 to 6 square x minus cos x divided by 3 x square. Again we apply, this is again of the form 0 by 0. and we apply L'Hopital's rule again, and we see 2 2 6 square x tan x plus sin x divided by 6x. Mm, mm, and if we bring out the sin x, because we have x in the denominator, if we bring out sin x common, we get 2 6 square x 1 by cos x plus 1 divided by 6x. So sin x by x tending to 0 will become 1, and the rest of the terms will have no problem. They are all cos x. So the limiting value becomes 2 by 6, 2 plus 1. This is 6 by 6 equals to 1. So limiting value of fx is 1 and gx is infinity. So the form becomes 1 to the power infinity form, and we can, using direct formula of 1 to the power infinity, we get the result as u to the power x tending to 0 fx multiplied by gx multiplied by fx minus 1. This becomes 2 by x square 2 by x cube tan x minus sin x minus 1. This is let's keep the 2 outside. This becomes 2 tan x minus 2 sin x minus x cube divided by x to the power 5. Now it's better to use the expansion series formula of tan x and sin x. It will be more easier to solve. We could have also used L'Hopital's rule, because the limiting this limiting function has the form 0 by 0. But since we are having x to the power 5, it will take a lot of steps to finally get the answer. So it's better, it will be much easier and faster if we use the expansion formula of tan x and sin x. So if we by using the expansion formula tan x and sin x, we get, this becomes, tan x expansion formula is x plus x cube by 3 plus 2 by 15 by x to the power 5. We will not go beyond x to the power 5, because in the denominator we have x to the power 5, like this, minus the expansion formula of sin x is x minus x cube by 3 factorial plus x to the power 5 by 5 factorial minus so on. In the end, we have x cube divided by x to the power 5. Now 2x to minus 2x gets cancelled, and we need to check whether x to the power 3 gets cancelled or not. Let's see. It should cancel. 2x gets cancelled. Uh, uh, let's complete the power of uh, x cube. It becomes 2x cube. The power x to the power 5 is plus 4 by 15 x to the power 5 and so on minus plus 2 uh, minus, we have already cancelled out the 2x and trying to see the remaining result. Here we have minus 2x cube by 6 minus 6 plus 2x to the power 5 by 5 factorial and so on. Finally, minus x to the power 3. This becomes x to the power 3. If we merge x to the power 3, if we combine all the terms of x to the power 3, we get 2 plus 2 by 6. Uh, x, there should not be any term x to the power 3. Let me check if I've used the correct expansion formula for tan x and sin x. 2 tan x is this, okay. Oh, sorry, x cube by 3. This will be 3. This is 3 and x minus x, okay. So this becomes 2 by 3 2 by 3 and minus 1 x cube, and if we merge the term of x to the power 5, we get 4 by 15 4 by 15 minus 2 by 5 factorial. mm, 2 by x to the power 5 plus 2 by 5 factorial. Four by 15, 2 by 120 x to the power 5 and more higher powers of this will be higher powers of x starting from x to the power 7, so it will be like uh, k into higher power of x to the power 5. So clearly the x over here this is 0, so x cube, we are not having any term containing x cube, so it becomes what is this, 160, 4 by 15 minus 1 by 60. If you divide, we have in the denominator x to the power 5, so then we divide the numerator by x to the power 5, we get mm, this thing plus uh, we get 4 by 15 minus 1 by 60 plus uh, some power of x to the power 7 and so on, some constant x to the power 7 plus so on. This becomes 4 by 15 minus 1 by 60, 16, how much is this? 4. 16 minus 1 by 60, 4 half. This is e to the power 15 by 60 is 1 by 4. This is e to the power half. E to the power half is the answer. Now, problem number 8. It says limit x tending to 1, x to the power n minus 1, n x minus 1 whole to the power 1 by x minus 1. Gx is tending to, definitely Gx is tending to infinity. So we must have the fx tending to 1, but it's better to check that out. X tending to 1 implies Gx tending to 1 by 0 tending to infinity. And what is fx is x tends to n minus 1 by n limit x tending to 1 fx is limit x tends to 1 x to the power n minus we have a standard formula. If we bring the 1 by n outside, we get and this is a standard formula where the answer is limit x tends to a x to the power n minus a to the power n divided by x minus a is n into a to the power n minus 1. Over here a is 1. So this limiting value will be n into 1 to the power n minus 1. This is n by n. This is 1. So basically fx is tending to 1. Therefore we have 1 to the power infinity form. So now we can use direct formula using the direct formula of 1 to the power infinity. We get the answer as e to the power fx minus 1. This is what is fx minus 1. Gx is this fx minus 1 x to the power n minus 1 n minus 1 minus 1. This is x to the power n minus 1 minus nx plus n divided by n hmm. Mm, okay. This is limit extends to now this limit is of the form 0 by 0. So we apply L'Hopital's rule, L'Hopital rule, and we get n x to the power n minus 1 minus n divided by 2n x minus 1. This is again of the form 0 by 0, and we again apply L'Hopital rule and get e to the power limit tends to 1 n into n minus 1 x to the power n minus 2 divided by 2n divided by 2n. Now we can substitute the value of x as 1 and we get e to the power n minus 1 by 2n, which is e to the power n minus 1 by 2 is the answer. So that is the end of this of the solution of this DPP. Thanks for watching. If you find this video useful and beneficial, then please support me by subscribing to my channel, and also like this video and share it with your friends, and do not forget to press the bell icon so that you will be notified by my future videos. In the next video, I will start the indeterminate form 0 by 0 and infinity by infinity. So until the next video, take care and bye.